Dear students, today we will discuss about PDV work. PDV or that is displacement work. Before going to PDV or displacement work, let me explain what is work done. Work done equal to force into displacement. Force into displacement. The mechanically, but in thermodynamics, work is done. Work is done when boundary of a system, may expand or contract. In thermodynamics, work is done when boundary of a system may expand or contract. Expand or contract. Let us. This is a thermodynamic system. It may expand. If expand, work is done. If the system boundary contract, also work is done or work is transferred. So when work is positive and when it is negative, it is notation. If work done by the system, it is positive work. Work done by the system, it is positive work. Work done on the system taken as negative, it is negative work. Positive work done by the system. When negative, work done on the system. Let me explain PV work done or displacement work done. Let us consider cylinder piston arrangement. A cylinder and this is piston having pressure P1 and volume V1. At position 1, that is at initial state. If piston displaces some distance, let dl distance Then finally, the properties are pressure P2 and volume V2. Here V1 increases to V2. Obviously, pressure P1 decreases to P2. The final position 2, 1 to 2. Del W equal to force into displacement. Again, we know pressure equal to force per unit area. P equal to F by A. All that implies F equal to P into A. Pressure into cross-sectional area A. And putting the value of A in this equation, we have PA dl. So what is A dl? Area into displacement dl is change in length. Area into change in length equal to change in volume, that is dV. P dV. So it is named so PV work done. PV work done. Then we will calculate PDV work done on various quasi-static process. Various quasi-static process. Quasi-static process. Quasi-static process means very slow process, that is reversible process. Various quasi-static process are: number 1, reversible constant pressure process. Reversible constant pressure process, that is isobaric process. It is also called isobaric process. The prefix iso means equal, baric means pressure. That means pressure equal pressure. That means pressure equal to constant. Previously we have derived del W equal to PDV. On property diagram, that is on PV diagram, P on y-axis, V on x-axis, and P equal to constant like this, 1 to 2. P equal to constant. This is the plot or the graph on PV diagram. So work down from 1 to 2, and we will integrate del W. Integration del W from 1 to 2 equal to integration PDV from 1 to 2, right? As work is a path function and del, that is E the exact differential. So we have write like this. W122 like this. P is constant, so take outside of that integration PDV from 1 to 2. The integration of dV, that is V P V, limit tends to 1 to 2. Then upper limit minus lower limit is equal to P V2 minus V1. This is the final expression for reversible constant pressure process. And graphically, work done equal to area under the process or area under the curve. This much area under the curve. Graphically representation to calculate the work done. The next process is number 2, reversible constant volume process. Reversible constant volume process, or that is isocoric process. Isocoric process. Coric means, that is a Greek word. Coric means volume. And prefix iso is equal, so V equal to C. On property diagram, like this, parallel to p-axis and perpendicular to v-axis. V constant, volume constant. So work done equal to del W equal to PDV, as it is constant volume process, and dV equal to obviously 0, and PDV, P into 0, obviously work done equal to 0. Graphically also 0. Area under the curve, no area, only the point. The next process is reversible constant temperature process. That is isothermal process. Isothermal process, or reversible constant temperature process, also where the process PV equal to constant. Isothermal means P equal to constant. The equation is PV equal to constant. According to general classification, we know that PV by P equal to constant. That implies PV equal to T into C. So PV equal to T is here constant. Constant into constant equal to another constant. So PV equal to C. We also written like this, that implies PV equal to P1 V1 equal to P2 V2 equal to and so on equal to constant. Then work on del W equal to PDV. So P, that implies P equal to P1 V1 by V from this above equation. Put the value of P in this equation. P1 V1 by V dV. Now integration 1 to 2. P1 V1 equal to constant. Take outside. P1 V1 1 by V dV from 1 to 2. Integration of 1 by V dV equal to ln V. P1 V1 ln V dV tends to 1 to 2. So ln V2 minus ln V1 ln is equal to ln V2 by V1 is equal to P1 V1 ln V2 by V1. From this equation, V2 by V1 equal to P1 by P2. Or this equal to P1 V1 ln P1 by P2. The next process is polytropic process. Polytropic process. The equation is PV to the power n equal to constant, where n is a constant and known as polytropic index. Polytropic index. And the value of n equal to 0 to infinity. If the value of n equal to 0, then P to the power 0 equal to constant, V to the power 0 equal to 1 means P equal to constant. P to the power n equal to constant, then P to the power 0 equal to constant means V equal to constant. On property diagram like this, P equal to constant 1 to 2, P equal to constant, here the value of n equal to 0. If the value of n equal to 1, then PV to the power 1 equal to constant means PV equal to constant. This is isothermal process. PV equal to constant, n equal to 1. And if n equal to 1.4 equal to the gamma, the equation is PV to the power 1.4 equal to constant. This part, PV to the power gamma of 1.4 equal to constant, n equal to 1.4. This is reversible adiabatic process or isentropic process. And like this: n equal to 2, n equal to 3, n equal to 4. Finally, if n equal to infinity, n equal to infinity is isochoric process. V equal to constant. Then work on del W equal to PD v to the power n equal to p1 v1 to the power n equal to p2 v to the power n and so on equal to constant. So p equal to p1 v1 to the power n divided by v to the power n. p1 v1 to the power n divided by v to the power n dv. Integrate from 1 to 2. p1 v1 to the power n equal to constant. Taking outside p1 v1 to the power n 1 by v to the power n dv. v to the power 1 by v to the power n is equal to v to the power minus n, and p1 v1 to the power n v to the power minus n plus 1 divided by minus n plus 1. Limit tends to 1 to 2. Then p1 v1 to the power n, putting upper limit and lower limit, we have v to the power minus n plus 1 minus v1 to the power minus n plus 1 divided by minus n plus 1, and p1 v1 to the power n into v to the power minus n plus 1 minus p1 v1 to the power n into v1 to the power minus n plus 1 divided by minus n plus 1. Again, p1 v1 to the power n equal to p2 v to the power n, p2 v to the power n, v to the power n into v to the power minus n plus 1 is equal to p2 v2 minus n plus n, when you cancel p2 v2 minus. Similarly, this is p1 v1 divided by minus n plus 1, or is equal to p1 v1 minus p2 v2 by n minus 1. p1 v1 minus p2 v2 by n minus 1. Similarly, for reversible adiabatic process, the work done will be p1 v1 minus p2 v2 divided by gamma minus 1. Instead of n is equal to gamma, and the value is 1.4. Okay, thank you.